Hello and welcome to the Cluster API Deep Dive, a sub-project of SIG Cluster Lifecycle.
Hi, so first of all, who are we? My name is Hardik. I work for SAP and I have been involved in Kubernetes from last like 3 years and so. And prior to that, I worked on my thesis, which was on container orchestrations.
And I'm Jason DeTiberus. I've been involved with operational lifecycle management for Kubernetes clusters since early 2015 and currently involved with the Cluster API project. I want to make it so that nobody else has to build like the base plumbing for building that installation and operational lifecycle management tooling again. So what are we going to talk about today? We have the motivation for why the Cluster API project was started. What is Cluster API? How do you bootstrap Cluster API? Because, yeah. You can't hear me? Okay. We're good? Okay. So what we're going to talk about today is the motivation behind the Cluster API project, what Cluster API is, how do you bootstrap Cluster API because it's Kubernetes managing Kubernetes clusters, and how can you get involved in the Cluster API project?
Okay, so before we get into the details, do a deep dive, I think I would like to set up the stage first. That why do we even do this? Why when we started this project? So first of all, in terms of the cluster management, the user stories have been really evolving. So there were days when we wanted to manage one cluster very nicely, but then now the use cases are evolving, and now we want to manage multiple clusters, and we want to manage multiple clusters in a uniform ways. We want to make sure that these clusters are running on different cloud providers, sometimes on-prem providers. We want to make sure they are scalable, they are, okay, there's still folks showing up. So now we want a lot more, and user stories are continuously evolving. And if you look at the existing ecosystem, then you see that we do have some nice tools. Like we have tools like kubeadm. It does a great job. It manages but only one cluster, and there is still a lack of infrastructure management. That if you want to use a kubeadm, you basically still lack that. If your VM goes down, then you still need there's still a gap that you want to somehow make sure that someone has to go back and start the VM again. So not just that, but then there is also a requirement in terms of the uniform automation. So now the phase has come that there are nearly like 70 different ways of creating a Kubernetes clusters and around 100 installers around. So unless your use case tightly packs into that one particular installer, you have bad luck. So we want to change that a little bit. With this project, we don't really want to create yet another installer, but we basically, rather than competing with the existing set of installers, we want to complement them in a way that Cluster API could become a mechanism using which we could add additional automation on the existing installers and existing providers. So very nice example is Cluster Autoscaler. So if you're aware of the project Cluster Autoscaler, then what it does basically, it's an amazing tool. It's basically based on the workload, it scales up your clusters, scales down your clusters. It's great. But for each provider, you have to create a separate plugin inside the Cluster Autoscaler. But then there are so many other tools which has similar requirements. Now, what we are targeting with the Cluster API is that if you can create only one provider which plugs in the Cluster API, then Cluster API itself abstracts all of the cloud provider. Then you get the feature of Cluster Autoscaler for free across all of the cloud providers. And then there are so many other tools like NPD and so on, and Node Auto Repair. You get all this feature free for all the rest of the cloud providers. So that's more or less is the vision. With this approach, we also see a need that with the large corporations, now there is a requirement of even internally offering the managed Kubernetes services. So we always wanted to provide a way in which you can always configure your cluster, your cluster to be provided to the customer in as much tight way as possible. So we want to avoid a lot of opinions at the Cluster API layer, but if there are opinions needed at the use case based, which are required to be supported by the customer, then we want to offer such mechanisms. Yep. So, simple definition, what is Cluster API? So Cluster API is, first of all, a sub-project under SIG Cluster Lifecycle. And the simplest possible definition is that it's basically an effort to bring Kubernetes-style APIs to create, configure, and manage multiple clusters.
All right, so at a high level, what is Cluster API? Basically, it's a way for a user to provide some type of declarative config to the Cluster API controllers, and on the other end, get some type of Kubernetes cluster. And that Kubernetes cluster isn't tied to any particular cloud provider, and you can potentially deploy clusters across multiple cloud providers. So how do you actually create those? There's 5 API types that we expose. They're CRDs, custom resource definitions. The first one is a cluster. The second one's a machine set, machine deployment, and machine class. And because we wanted to bring familiar concepts that users would already know from using Kubernetes, we tried to tie in some analogs to existing types. So for example, the machine is kind of analogous to a pod. A machine set is a way to manage multiple pods in a repeatable way. A machine deployment's a way to have declarative updates to a group of machines. And machine class is sort of analogous to a storage class. It's a way to define a specific type of config and be able to reuse it in different places.
Okay, so let's get started now. So as I already mentioned, Cluster API is basically nothing but a bunch of CRDs. So the topmost CRD is called Cluster CRD. So in the Cluster CRD, we integrate the information which is applicable cluster-wide, which is applicable across different Kubernetes distribution, and which is a common layer for all the clusters, which could include, for example, the pod seeders, or you want to include the service seeders or the node seeders and so on. So all this networking layer can be baked inside here. Then you would also see that we also provide in the status field something like the endpoints. So if you want to build the higher level features on top of the cluster object, then such status field which tells you that what is the API server's endpoint, whether it is available or not, and so on. So this kind of information then gets into the cluster CRD itself.
All right, and also providers can override the behavior. They can do whatever's needed for implementing the shared cluster objects and the core cluster components for their particular cloud provider.
Yeah. Then it comes the machines. So it has been very interesting with the machines that in Kubernetes world, we always knew that Kubernetes did a great job of managing the workloads, but machine itself has been out of the scope for quite some time. So if you have a very nice cluster running with very nice workload, but if out of the blue your machine goes down, then you don't know who will gonna take care of it. So that's where we are trying to bring the idea where machines can also be reconciled at the same Kubernetes control plane layer. So that's where the CRD of the machine kicks in, and this machine CRD basically includes the details that how do you represent an exact machine on the cloud provider, and what are the information required to convert that particular virtual machine into the Kubernetes node, and how to maintain the state of that one particular machine. And same also applies in terms of providers. If you have a separate cloud provider, then we always want to provide a way that you can override the existing behavior and hook in your own specific behaviors. Then we go to the machine set. So as Jason already mentioned, all of us are pretty much aware of what is replica set. What it does, it just makes sure that there is always a replica of machines available and healthy. That's what exactly machine set does for the machines. So if you tell the machine set that I want 3 replicas of the machine with a given state, the job of the machine set controller is going to be to maintain those machines in any case. And then at the end, machine deployment. So we always know that day 0 of creating machines and having cluster is always good, but then the real challenges come when you want to upgrade, and there was always a requirement that how do you efficiently upgrade your existing Kubernetes cluster. So upgrading the application, you can do a lot of things there, but upgrading the machine also has some challenges. For example, if you have a machine with certain version, with certain OS image, and then suddenly you get the security flaw, and then you are saying that, oops, now I want to replace all of the machines of my cluster with a newer version of the operating system that fixes the security flaw. So what are the ways to do that? You probably might not want to manually go and delete them. You might not want to probably do it randomly. So with the machine deployment, we can bake in the logic the way we do it with the deployment controller. So you can systematically apply the strategies like rolling update, where you can mention that, hey, I want a max unavailable of only 1 and max surge of only 2, which means you do the rolling update, you bring down the machines, create new machines, but at any point in time, only 1 machine should be down. So those kind of situations or this kind of exact scenarios can then be taken care by the machine deployment controller. Then we go to this provider spec. So as we mentioned, that all this controller is the most essential part is to talk to the cloud provider. And as we know, that we have so many cloud providers, and there are ways where they differ to each other. A simple example, if I want to create a machine on AWS, then kind of information, kind of keywords I have to use is slightly different than when I want to do the same thing on the GCP or Azure or VMware or somewhere. So that's where this provider spec blob kicks in, where inside the machine object, we have one row extension where you can mention that, hey, for my cloud provider, these are the set of keywords to be used. You put it there. The shared controller do not really care about this blob, but whatever you will see later that whatever are the external providers for the cloud provider integration, whatever plugins are being installed, they will basically interpret this particular blob. And then we immediately started seeing a concern as well, so that this provider spec, you might not, so first of all, we know that we probably don't want to have completely heterogeneous machines in a cluster. It's very common that we want to have pretty similar machines in a given Kubernetes cluster, right? So then we see that we don't really necessarily need to have to be so redundant and manage the same provider spec across here and there. So then we introduced the idea of machine class, where you can externalize the provider spec blob from the machine object and maintain it separately, and that brings some real nice benefits as well. For example, you can do the defaulting, you can use the nice validation hooks on top of it, and not just that, with the concept of the machine class, which is also very similar to the storage class, the external toolings like Autoscaler, again, can consume such machine classes and give us a much advanced feature, which is actually not possible even in Autoscaler for the rest of the cloud providers.
Yep, so how does it actually work and how do you deploy it? So if you already have a Kubernetes cluster and you want to turn it into a cluster API management cluster, you deploy basically at least 2 components. The first one is the cluster API controller manager, and that manages your machine sets and your machine deployments, because the logic for those and how do you maintain them doesn't actually require the cloud provider integration. And the next component that you need is you need at least one provider-specific controller manager. And generally, these have been built with KubeBuilder. They don't necessarily have to. You can actually build the controller up from scratch as long as you implement the API types and the behaviors. But all of the cloud providers that I know, all of the providers I know that exist today, all use KubeBuilder, and they also consume some common logic from the Cluster API project itself. And most of this is around the general control loops and making sure that we're handling deletion properly and all of the things that kind of make implementing a controller more difficult. And then each of the provider implements what we call an actuator interface, which is a smaller interface where they can focus more on the actual logic that's needed for actually interacting with the cloud provider. So for example, for the machine, there are 4 methods that are exposed: create, update, delete, and exists. So when you implement the machine actuator, that's the only logic that you have to do, and it maps pretty well to the actual cloud provider SDKs usually. So, as we said, you need a Kubernetes cluster to deploy Cluster API. So how do you get that in the case that you don't already have one? So we provide a tool called Cluster Cuddle, which allows you to basically bootstrap a Cluster API management cluster from nothing. So the first thing it does is it'll generally create a local bootstrap cluster. You can choose between using Kind, which we generally recommend as a project, or you can use Minikube if you still want a local cluster, or if you already have another Kubernetes cluster and you just want to take advantage of the deployment logic, you can point it at an existing external Kubernetes cluster. So after that bootstrapping cluster is up, it deploys the cluster API controller manager and the provider controller manager. It also installs some additional RBAC and the CRD definitions and everything it takes to actually deploy a CRD-based controller. And then it goes ahead and applies a cluster object and a machine object to that cluster API management cluster. And the next step is you actually get a cluster running in the cloud provider that you chose to run with Cluster Cuddle. But right now, you have a local management cluster sitting on your desktop or some other existing Kubernetes cluster, and this new cluster sitting out there. So in order to actually turn it into a management cluster, we need to actually, what we call pivot, move the cluster API components to this new target cluster and all of the resources as well. So I've kind of simplified, like, wait, where am I? Yep. So at this point, we haven't yet pivoted. At the end of the pivot, everything's over there. It's not quite that simple though, because if we just do it that way, if we just moved everything over and didn't take into account order, there's a whole lot of things that could go wrong. The first is if we don't ensure that we shut down the controllers on the bootstrap cluster before we migrate them over to the target cluster, we can end up with a situation where we have two different sets of controllers reconciling the same object, and they could potentially be fighting against each other, trying to affect different changes on the cluster. So we actually shut down, or well, we scale down the controller managers on the bootstrap cluster. We deploy the components on the target cluster. And then there's also ordering that's required for the different API resources as well. So we generally do a stage approach where we first move over the cluster, then we move over machine deployments. No, we don't. We don't send over the machine deployments. We move over machines first, machine sets and machine deployments. If we actually move the machine deployments over first, those machine deployments would try to create new machine sets, which would try to create new machines, and you would actually scale up your cluster during the pivoting process. So that's not something that we actually want. So we handle in Cluster Cuddle the logic that you need to actually pivot the cluster safely.
Also to add on that, so pivoting is something that we tried out because we saw a problem that we are developing nice controllers and the use case is different here. So in all normal cases, we assume that, hey, we have a cluster, now I'm creating an operator. But here, if we say that you already need a cluster, before you can use something which is going to manage more clusters, then that sounds slightly hazy. So, but also very important to mention that, which is also a very famous use case, even in the cluster API, that if you already have an existing cluster, if you are ordering from any of the existing managed services of any cloud provider, then you can hook the same logic with that cluster as well. So, which means, if you try to imagine it, it would look very simple that you already have a base cluster, which could be your management cluster, and then you tell that management cluster that, hey, install my cluster API controllers and machine API controllers on that one particular cluster, and then that's pretty much all. You start creating your cluster.yaml the way you create any other .yaml files in operator world. The moment you create the cluster.yaml, the cluster API controller will interpret the cluster and actually start creating the real clusters for you. And that's what also we are still in a very early stage in defining that what should be the responsibilities in terms of the management cluster and what could be the right way. It's a very early stage here, and there could be some changes coming in as well.
Yeah, I think that's a great point. The only time you ever need to go through this pivot workflow is for that you don't have an existing Kubernetes cluster and you need to go from 0 to cluster API. And actually, there's the final stage of that where we just delete the bootstrap cluster because nothing's running on there at that point.
Oh, yes. So getting involved. So we wanted to keep this presentation as lean as possible and open up for a Q&A as soon as possible. And also for getting involved, we are in a strong need of new people who can help us developing it further. And if you see, it's not always, I think there is a myth that to contribute, you always need to have coding skills. That's not really true. There is a requirement of project management. We need people who can triage different issues. We need people who can basically help us in documentation here and there. But that does not really mean that coding skills is not required. This is as important as it goes. And if you really want to get into the project, then the good starting point is to check out the issues which are tagged with good first issues or help wanted and so on. So these are the set of issues which are something which could be a very, very small, non-disruptive changes and can become a good starting point for you guys. And of course, if you are belonging to a certain cloud provider and you want to add support in the existing Cluster API, then you can always add the support, or we have a very vast community already you will see later that there are so many providers who have already created a PR on the Cluster API and they are still developing their stuff. You can check if you are not there, you can add your own support, or if you are expecting a certain facility from certain provider, then you can try to enhance it. And some more information, this link to the Cluster API, you can always subscribe to the SIG Cluster Lifecycle. And we have weekly meetings every Wednesday, 10 a.m. PT, Pacific time. All of the Cluster API folks meet there. And if you check our Cluster API channel, I have to say that it's one of the most active channels in the community right now, that there are so many very good topics being discussed because this topic has been resonating with very large number of companies, and everyone knows, and we are getting very good feedback from here and there. It would be very nice, or I would say this is a very good time. If you plan to get into this Cluster API collaboration, probably you should check out this Slack channel as well.
And I would add that in a lot of cases, some of the provider implementations, they have additional discussions outside of the main Cluster API channel. The AWS provider has Cluster API, AWS, and a lot of the other ones are actually also available for answering questions in the SIG-related channels related to those cloud providers as well. Speaking of providers, we have a few provider implementations that we've kept track of in the Cluster API project. This is all available in the README. There's AWS, Azure, Baidu, Bare Metal. You know, there's many different provider implementations. They currently all vary in the quality of them and the support, but you know, there's likely something already out there for the cloud provider that you're interested in, and there are other ones that haven't been PR'd to our repo as well. Not only that, there's another use case where we have projects or products that aren't ready to adopt all of Cluster API in one go. Or maybe they just don't have a use case where they need all of Cluster API. We also want to enable people to adopt portions of that API to build the tooling that they want as well. And these are 3 examples of projects that are already adopting portions of Cluster API today.
So to mention, one of the also not very strict, but goal is that with this effort, we want to define, or I would say we want to standardize across the community that how do you describe a cluster. And it doesn't matter which provider you are talking to, doesn't matter which installer you are using for your cluster deployment. We want alignment across the community that this is how you describe one cluster, this is how you describe a machine, this is how you describe the machine sets, and so on. And with that alignment, we will see a very nice portability in the future when the project goes ahead, that you would have only one specification which will talk to all different environments all across.
Yep, so we said we wanted to leave a lot of time for questions. And the main reason for that is I had originally planned to talk about the future roadmap of Cluster API, but we're still working on it. As a community, we're trying to figure out what exactly that next step is to V1 Alpha 2 and beyond. We'd initially taken a very ambitious roadmap on, and we wanted to try to see if we can come to some large consensus around big changes in the project. And we're not quite there yet, so we're going to take a little bit more of an iterative approach for the short term, try to get feature development done, try to solve problems that people are facing right now. But at the same time, we're going to continue having those conversations as a community about how we expand the project longer term. So I don't have anything concrete to speak about the roadmap, but I wanted to give people a chance to go ahead and ask questions that they have, you know, regarding what cluster API is today, or even potential roadmap for the future.
Okay.
Yeah. Oh, okay.
Thank you very much for the presentation. My main question revolves around autoscaling, which you mentioned briefly, and how, when we currently use the cluster autoscaler, does that in any way get counteracted by a bootstrap via cluster API, or is it just transparent? And the follow-up would be, I would really like to see something more standardized in the cluster autoscaling space, which you already mentioned, especially in a way where different cloud providers do different things in terms of node pools and are very opinionated about the way scaling should work.
I think that's a very good question. So cluster autoscaler is, I would say, the low-hanging fruit for our project. And so how does it work at the moment? As you already mentioned, that it's very dependent on the cloud providers. So Autoscaler uses ASG for AWS. It uses something else for GCP, something else for Azure. And all of this has to be maintained inside the entry of the cluster autoscaler. Now, what we are trying to do with the cluster API, so if you get the concept of the machine deployments, so what does it do basically? It helps you in scaling up and down the machine objects, and there is an abstraction that this object does not really need to know which cloud provider it is running on as such. So now what we are trying to do is that the cluster autoscaler directly manipulates the machine set or machine deployment rather than manipulating the ASG or something on GCP or something on Azure and so on. So with that way, there is already a PR on the autoscaler which is being reviewed, and there is already, so we also had a cross-community meetings for the same reason, that with the autoscaler community and the cluster API community to figure out what are the gaps and what are the requirements on both the sides to make it work. And we have some consensus there, and I think there is already a PR there. You will see it working soon, hopefully.
So, and I would say that the PR that's out there would be an initial integration. You know, one of the things that we're looking at is how do we implement it short term, and there are certain limitations with the architecture of the autoscaler and the architecture of cluster API that create a little bit of an impedance mismatch on, you know, the autoscaler wants to determine exactly which nodes to take out of the cluster, and, you know, there are particular reasons for that. You know, they want to take into account scheduling concerns and make sure pod disruption budgets are being honored. And Cluster API doesn't have any support for that right now. So how can we share efforts and share kind of that code and logic for doing that so that we can have a much cleaner integration than Cluster Autoscaler just tagging a specific machine instance and like trying to honor that in the machine set or the machine deployment management. So longer term, we want to have better native support and integration between the two as well. And the second question was around how do we provide better abstractions around the different cloud providers to fit in better with their kind of native tooling. So I had an interesting conversation with one of the developers from Microsoft specifically about this. They're interested in specifically being able to leverage the VMSS for managing their clusters, so similar to like an Amazon ASG. So I've requested that they put together a proposal so that we can actually start defining what does it look like. And my initial feeling is that if we try to implement it based on the machine level and the machine abstraction that we expose today, it is not going to be, it will be more complex and more fragile than it needs to be. I think we need to look at how do we extend something like the machine sets and provide either support at the machine set level or similar abstraction, similar machine set that sits natively over that scale group. And then how do we then do the proper things that are needed for managing that scale group? And that may mean doing some interactions with some of the things like the cluster autoscaler is to figure out exactly which machine to, you know, which machines to keep and which machines to delete out of that scale set. But, you know, it's a much easier abstraction to manage at that kind of set level rather than, you know, at the individual machine level.
Any other questions?
So it was a question about the machine actuator. I noticed you had the exists operation. Is that using some kind of liveness and wellness probe to, how does it understand whether a machine is healthy to keep the number of replicas kind of up to date?
Yep, so this is actually a challenge today. So if you are looking at a self-managed cluster, so you go through the cluster Cuddle workflow and you get a cluster that's running Cluster API and managing itself, then currently what it does is it basically inspects the node health and uses that to determine, is this machine healthy or not. That's not sufficient. We want to have better support for that. And we also want to be able to support, checking the state of nodes that are not local. We want to be able to, support reaching out to another one. And that's one of the roadmap items that we're trying to look at. And we don't necessarily have a clear path forward how to do it. We just know that that is something that we need to improve in the project.
This question there and here.
Could you please talk a little bit about cluster updates, cluster upgrades, like, for example, going from single master to multiple master or upgrading Kubernetes version? What's the status and what's the plans for that in the cluster API?
Yep. So in terms of the cluster updates, there are basically two parts. One is masters and the worker machines. So with the worker machines, you will, as I already said, you will have a very well-defined strategies with the machine deployment, which is already there, which is like either you can recreate all the machines. If you have 10 machines in the cluster, you can bring down all 10 of them together and bring 10 new machines, or you can have a very controlled way of upgrading the machines from one version to another version, where you can mention the max unavailable, max surge, and so on. And the plan there is also that if you have the applications running which are looking for PDBs, for example, so you have a cluster with certain application SLAs, where PDB is mentioning that on a cluster, I have an application, and that application instance, for that application instance, at any point in time, the max unavailable should not be violated, for example. So out of 10 instances of that application, there should always be 2 instances of the application available, irrespective of whatever you do on your upgrades or whatever, right? So those kind of things are also going to be taken care by the machine deployment controller, where because we are draining the machines before bringing them down, this drain logic in the machine deployment will consult that, hey, out of these 10 machines, the first 2 machines, I should not bring down those first 2 machines, because if I bring down those 2 machines, then the XYZ application's SLA might get violated. So there will be a very well-defined strategies there for the upgradation of the worker parts. For the dedicated masters, probably Andy can throw some light.
Hey everybody, I'm Andy Goldstein. I also work on Cluster API with Jason Hardik at VMware. So in terms of upgrading your control planes, we don't recommend that you deploy control plane machines as part of a machine set or machine deployment, because we don't have the logic built into those controllers to handle dealing with etcd joining and removing. So we recommend that you deploy the control plane as individual machines. And right now, all of the kubeadm, init, and join logic, or whatever you're using, whatever your provider is using to add nodes to the cluster, is built into each provider independently. So if your provider can handle init and join, which hopefully they all do, then adding new control plane nodes, whether they're the same version that you currently have or a newer version, should be handled automatically as part of the join process. Being able to delete old nodes, old control plane nodes as part of the upgrade is a little bit more of a challenge, because there's currently no logic in any centralized place, or I don't know if any providers have it, to remove the old machine from etcd. So take it out of the etcd membership so that the cluster is not trying to think it's still there. We are working on a tool that we'll be open sourcing soon that is basically a stopgap measure for doing control plane upgrades with Cluster API v1 alpha 1. And the purpose of this tool is to be able to handle both control plane upgrades and machine deployment-based upgrades. But in the end, we want to throw this thing away. We don't want it to live forever. We want all of the logic that we're building right now as a temporary measure to make its way into Cluster API proper as part of the roadmap discussions that we've been having over the past several months.
Thank you, Andy.
There's a question there. this question.
All the way in the back.
Hi, I have two questions. One question is regarding infrastructure applications. How will machine deployments support that? What I'm talking about is tying certain daemon sets to certain machine deployments that you don't want to run cluster-wide. And the second one is perhaps something for the real future, like the dreaming part that we heard this morning. Would it be possible to integrate the cluster API with Velero and do cluster upgrades that not only contain the applications, but even the cluster itself, and then restore from it?
So I can probably take the first questions, and second, Justin can take. So, so there is as such no plan that you will be able to create a daemon set for a machine deployment. That's in a very loose way, that's anti-pattern, because you have one cluster, and we would not probably be able to provide a feature or something where you can say, hey, creating a daemon set, but that daemon set only applies to this one particular machine deployment. But what we can provide is that we will be offering a way using which you will be able to maintain labels or annotations or taints on a particular set of machines. So when you create a machine deployment, you can tell that, hey, for this machine deployment, I want this label to be maintained on all of the machines which are belonging to this particular deployment. And then you know what to do next. You can always create your application in a way that right kind of labels are maintained.
All right, so for managing backups and using tools like Velero during upgrades, not natively. We don't want to bake in super opinionated workflows because they're not going to work for everybody. And we really want to build that common base that works, and just so that, you know, more projects can adopt this. And similar to KubeADM, it moves projects to working higher up in the stack and providing better value to users. So we want to enable those workflows. And for example, how we're looking at the control plane management and how do we define that? We've already identified kind of as a group that we see 3 kind of different high-level control plane management use cases for the first go-round. One is the machine-based, one is the pod-based, similar to what Gartner does today. And then the third one is being able to abstract away the different managed Kubernetes service offerings and being able to manage those with the same type of control plane object. And it should be, you know, one of the potential ways that something like that could work is basically, for better or worse, extending one of these types of control plane management extensions or plugins or however we end up calling it as a community, and tying in the specific workflows that you have. And specifically around management of etcd and making sure that your data is backed up and all of that, one of the things that we're also looking at longer term is there's also another project called etcd ADM that's a SIG Cluster Lifecycle related project. Once that matures a little bit more, we want to make sure that we can get integrations with that into KubeADM and with Cluster API as well. So we want to make sure that, you know, we're providing at least some level of backup using the common tooling, but then again, like something that's using more opinionated tool would be required to be, you know, added on additionally. Or if people have ideas on how they can provide hooks into that or extension points, that would be great to like have discussions around that. How do we enable that through like an extension mechanism so you can kind of pick and choose what you need to do those workflows.
I think we are also out of time. We can maybe we can discuss offline as well. This is a hard cut.
Hey, so my questions are around basically the machine set descriptions for each provider look very different, and that's great if you're running managed Kubernetes. But if you are self-managing your Kubernetes, there's a set of common things that you might want to do, like what the other person said, add labels and selectors that would probably tie into your CNI framework, or have verification, right? The minute you launch a node into the Kubernetes scheduler pool, you start scheduling pods, but you first want to verify since there are so many moving parts. Is can we have some of that thing, common logic pulled out so that it's easy for people to fork, say, Amazon or Google or Microsoft's implementation and add custom hooks on top of that?
So that's a very good question. It's a challenge because we want to provide the right abstractions. We want to bubble up the right information so that people can set things that are truly common across the cloud providers. What we want to avoid as we're building this out is trying to build some type of multi-cloud abstraction interface that tries to, you know, for instance, like how you do the different instance sizes across the different cloud providers, trying to provide a common way to abstract that. It's going to now create a new DSL for people to learn. Like, we want to avoid that, but where there is common config that we can bubble up, we do indeed want to do that. And I think one of the things that you mentioned specifically was related to how tightly the bootstrapping configuration for the cluster is tied into the actual provider implementations. And that's one of the things that as a community and a project we know we want to address. We want to separate those out so that you can provide the same kind of bootstrapping steps regardless of the underlying cloud provider. And I think that would get us a long way towards that, so that the bootstrapping separate, you can utilize the same type of bootstrapping tools and not try to abstract away kind of too much of the cloud provider implementation. And I think the other challenge is that by default, KubeADM has a very expressive config for how you do these things. We want to make sure that we also don't generate our own brand new cluster, you know, configuration, data types, and have to, like, you know, handle mapping between all of the various things too. So it's like a balancing act between what are the right abstractions over the different providers or extensions, and how we can enable ease of use.
Okay, I think we are seriously out of time. we are around, and if you have any questions, you can definitely discuss this offline. Thank you, guys.
Thank you.